In this lesson, we're going to dive into virtual private networks, also known as VPNs. So what is a virtual private network anyway? Well, a VPN or a virtual private network extends a private network across a public network and enables users to send and receive data across shared or public networks as if their computing devices were directly connected to the private network. With a VPN, your users can work in a remote office or work from home and telecommute simply by logging into their laptop and establishing a secure VPN tunnel to their organization's network, regardless of where it is in the world. To do this, they will connect to a VPN device sitting at the headquarters data center or your cloud service provider's data center. Then after that, establish a secure tunnel using a VPN protocol in order to allow a secure connection for the corporate user over an untrusted or public network, such as the internet. VPNs can be configured as a site-to-site VPN, a client-to-site VPN, or a clientless VPN. So let's dive a little deeper and talk more about a site-to-site VPN. With a site-to-site VPN, we can connect two offices together. A site-to-site VPN is used to interconnect two sites and provide an inexpensive alternative to dedicated lease lines. For example, let's pretend I have a branch office in California and my headquarters is in Washington, D.C. If I want to be able to connect my remote regional office in California to my head office in Washington, D.C., then I could buy a dedicated lease line from a telecommunications provider, and they will give me a direct connection that covers the 3,000 miles in distance between those two sites. Even if I got a low-speed T1 connection, this would be extremely expensive. But if I use a site-to-site VPN, I can save a lot of money. Instead of using a dedicated lease line, I could simply create a VPN tunnel from the regional office back to the headquarters over the public internet using the internet connectivity they already have in the office. This solution may only cost me $50 or $100 per month using a standard cable modem or fiber modem service from the location internet service provider. Once the VPN tunnel is established, it will take all the traffic from the regional office in California, bring it back to the headquarters in Washington, D.C. over the internet with a secure tunnel, and then decrypt it once it reaches the inside of the Washington, D.C. office network. Now, when a California user wants to go to google.com, the data will go from California to Washington, D.C. Then it will go out of that Washington, D.C.'s internet connection to visit that website, return to the Washington, D.C. office internet connection, and then go back through the VPN to the California office user to view the website that they requested. By using this site-to-site VPN, all of the traffic goes back and forth between California and Washington, D.C. is encrypted and secure. So no one can even see the internal network traffic, even though we're going through this external public internet connection. When we deal with a client-to-site VPN, on the other hand, we are sending data from one single host, like a laptop, a cell phone, a smartphone, or a tablet, and connect it back to our headquarters office instead of doing it from the site's router to the headquarters router. This allows only the remote user to be able to connect back to the head office, and that's why we call it client-to-site. Now, in addition to site-to-site and client-to-site VPNs, we have to decide whether we're going to use a full tunnel or split tunnel VPN configuration. Both full tunnel and split tunnel VPNs can be used with either site-to-site or client-to-site. A full tunnel VPN is usually used by default in most organizations, and it is what I described earlier. A full tunnel VPN routes and encrypts all network requests through the VPN connection back to the headquarters, regardless of where the destination or service is located. This is considered more secure, but when connected to a full tunnel, clients are considered to be fully part of the headquarters network when connected. This means that if you're trying to access a local area network resource, such as a wireless printer in your home office, you will be unable to do so because that wireless printer in your home office is not connected to the headquarters network like your laptop is over the client-to-site VPN connection. Conversely, you can still print to the printers in the headquarters office when connected using full VPN tunnel, even if you're sitting at a hotel room halfway across the world. A split tunnel VPN, on the other hand, divides the traffic and network requests and routes them to the appropriate connection or network. A split tunnel VPN routes and encrypts only the traffic bound for the headquarters over the VPN while sending the rest of the traffic to the regular internet. For example, if I'm using a client-to-site VPN on my laptop with a split tunnel from my home office, the VPN will decide which traffic to route over the VPN and which traffic to send directly over the internet. So if I'm trying to access a file server or a Microsoft Exchange mail server that is located on the headquarters network, those packets will get encrypted and routed over the VPN to the headquarters. But if I need to attend a Zoom conference or access Office 365, the traffic bound for them will go directly to those sites and bypass my VPN connection. This is why we call this split tunnel, because we have an encrypted VPN tunnel for traffic that needs to go to the headquarters and unencrypted direct internet path for everything else. The challenge with using a split tunnel is that they can be less secure because there's a possibility that an attacker could connect to your device over your unencrypted internet tunnel and then pivot through your laptop and send data over your VPN back to the headquarters network. For this reason, if you're connecting to a VPN from an untrusted network, such as Wi-Fi at a hotel or coffee shop, then you should opt to use a full tunnel VPN instead. A split tunnel does, however, give you better performance because it routes all of the internet-based traffic directly to those servers and bypasses the entire headquarters network. So as you can see, there are trade-offs between security and performance. For more security, use a full tunnel VPN. For better performance, use a split tunnel VPN. So far, we have talked about two main types of VPNs, a site-to-site VPN and a client-to-site VPN. There's one more type of VPN that we need to discuss. It is known as a clientless VPN. A clientless VPN is used to create a secure remote access VPN tunnel using a web browser without requiring a software or hardware client. In fact, you use this type of VPN every day without even knowing it. A clientless VPN is used via your web browser when it makes a secure connection to an e-commerce or other secure websites using HTTPS. This can be done using the SSL or TLS protocols. Now, the Secure Socket Layer, or SSL, provides cryptography and reliability using the upper layers of the OSI model, specifically layers 5, 6, and 7. In recent years, though, SSL has become a bit outdated and less secure. So most clientless VPNs are instead opting to use the Transport Layer Security, or TLS, to provide secure web browsing over HTTPS. So when you logged into a website and watched this video, you had to enter your username and password. If you saw that green lock on the upper left corner of the address bar, then you knew it had an HTTPS connection. This means that you are either using SSL or the TLS to create the secure clientless VPN tunnel from your web browser to your computer to our server to be able to pull these videos. SSL and TLS both use TCP to establish their secure connections between a client and a server. But this can slow down your connection since TCP has a lot more overhead than UDP connection does. So instead, you can opt to use DTLS, or Datagram Transport Layer Security, which is essentially UDP-based version of TLS protocol. This provides the same level of security as TLS, but operates a bit faster due to there being less overhead in the UDP protocol itself. DTLS is an excellent choice to use when you're wanting to provide video streaming and things like that over a secure encrypted tunnel. This provides the end user with security over UDP and prevents eavesdropping, tampering, and message forward that can sometimes happen in clientless VPN connections. But the truth is, in most modern VPNs, we're going to see IPsec or IP security. IPsec is used in virtual private networks to provide authentication and encryption of packets to create a secure encrypted communication path between two computers over an internet protocol-based network. For now, let's just remember there are three main points of VPNs: site-to-site, client-to-site, and clientless. Also remember, there are two methods of communication using VPN: full tunnel and split tunnel. And finally, remember that there's a lot of different protocols that we use, but most of us are going to end up using the IPsec to establish our VPN connections.